At 4:17 a.m. on April 29, 1942, Corporal Ted Parsons watched Air Vice Marshal Hugh Lloyd step into the bombed-out radar bunker on Malta's Dingley Cliffs, knowing the next 90 seconds would determine whether 250,000 people could survive another month of siege. 23 years old, 9 days rebuilding equipment with washing machine parts, 0 engineering training. Lloyd's message was clear: show me it works, or we evacuate every fighter to Egypt by dawn. Malta had endured 2,300 air raids in 4 months. The island held the world record for most concentrated bombing in human history. More explosives per square mile than the London Blitz. Standard radar gave 12-minute warning, insufficient for RAF fighters to reach combat altitude. Axis bombers were destroying supply convoys at 85% success rate. The island had 6 weeks of food remaining. If Malta fell, North Africa would fall. The Suez Canal would close. Churchill called the situation critical beyond measure. If you like stories like this, true moments where human instinct quietly changed the course of history, consider subscribing. German bombing on April 20th had destroyed Malta's main chain-home radar station. A 500-kilogram bomb hit the transmitter building at RDF Station 31 on Dingley Cliffs. The transmitter survived. The rotating mechanism that turned the antenna was obliterated. The receiver array shattered into fragments. Communication cables severed. Replacement parts required 8-week shipping from Britain through submarine-infested Mediterranean waters. Without early warning, RAF fighters were flying blind. The Luftwaffe had air superiority 18 hours per day. Malta's 3 remaining Hurricane fighters, down from an original complement of 60, couldn't defend against formations of 80 to 100 German and Italian bombers arriving without warning. Parsons was a radio repair technician from Portsmouth. No university education. He'd been trained on peacetime civilian radio equipment, vacuum tube receivers, and commercial transmitters. The military assigned him to Malta in January 1942 because they needed bodies, not because he had specialized skills. But Parsons had spent 3 months obsessively studying the chain-home radar system. He understood the principles. Radio waves transmitted, bounced off aircraft, returned to receiver. Measure the time delay, calculate the distance. Rotate the antenna, determine the bearing. Simple physics. Impossible engineering. On April 21st at 2 a.m., Parsons drew modification plans on the back of a ration card. He showed them to Flight Lieutenant James Caldwell. The plans called for salvaging a rotating motor from a destroyed Italian washing machine in a bombed Valletta laundry, using bicycle chains from an abandoned shop to connect the motor to the antenna base, rewiring the receiver array using telephone cables from a collapsed post office building, creating a makeshift amplifier from destroyed Marconi radio parts scattered across the island. Caldwell looked at the sketch. This is either brilliant or insane, probably both. You have permission to try. We're dead anyway if you fail. The first test on April 23rd at dawn revealed cascading problems. The washing machine motor wouldn't synchronize with the antenna rotation speed. Signal detection range measured 8 miles. Standard chain home range was 40 miles. The bicycle chain kept slipping under load. The improvised amplifier overheated after 6 minutes of operation. Parsons needed the antenna to rotate at 60 RPM. The washing machine motor ran at 400 RPM. He created a gear reduction system using aluminum panels from destroyed aircraft, welding them into makeshift reduction gears. The motor still overheated after 30 minutes. The modified amplifier drew too much electrical current. Malta's power grid was damaged from months of bombing. Available power was 60% of normal capacity. Parsons rewired the radar's power system to draw from a generator meant for anti-aircraft searchlights. He had to convince the battery commander to sacrifice his searchlight power. The commander agreed only because the alternative was total blindness to incoming raids. On April 26th, Parsons realized his improvised receiver could only detect bombers at 15 miles. RAF Hurricanes needed 25 miles minimum warning to climb to interception altitude. The problem was impedance mismatch. The telephone cables he'd used had wrong electrical characteristics. He needed proper coaxial cable. None existed on Malta. Then he remembered seeing damaged underwater telegraph cable in Grand Harbour, destroyed when Italian frogmen attacked British ships months earlier. The cable was 40 feet below the surface. Parsons had no diving equipment. He dove 7 times, holding his breath, cutting sections of cable with bolt cutters in 58-degree water. Each dive lasted approximately 90 seconds. On the 7th dive, he cut free a 200-foot section and dragged it to the surface. By April the 28th, the system was detecting signals, but it detected everything: birds, weather patterns, fishing boats returning to harbour. Operators couldn't distinguish bomber formations from background noise. Parsons needed frequency filtering. He salvaged capacitors from destroyed civilian radios and calculated the precise values needed to filter unwanted signals. He did the mathematics with chalk on the concrete bunker floor because paper was scarce. His first calculations were wrong. The filter didn't work. He recalculated at 1 a.m. on April 29th. The second attempt succeeded at 3:30 a.m. 90 minutes before Lloyd's deadline. Intelligence reports indicated a major Axis convoy operation scheduled for April 30th. Expected bomber count exceeded 200 aircraft. Without working radar, the RAF would be annihilated on the ground. Lloyd had ordered evacuation of remaining fighters to Egypt if the radar wasn't operational by 5 a.m. on April 29th. When Lloyd arrived at the bunker at 4:17 a.m., Parsons had 43 minutes remaining. "Show me it works, or we evacuate the fighters." Those were Lloyd's exact words. Parsons powered up the system. The washing machine motor hummed, an industrial sound completely wrong for military equipment. Bicycle chains rattled against their improvised housing. The antenna rotated, wobbling slightly from the imperfect mounting. The oscilloscope displayed static, green phosphor snow dancing across the screen. 30 seconds passed. Nothing but static. 60 seconds. Still static. Lloyd checked his watch. "Corporal, I'm giving you 30 more seconds." At 82 seconds, a strong signal appeared on the oscilloscope. Bearing 095, range 38 miles, single aircraft, high altitude, bearing 095. Lloyd radioed harbour control. "Any expected arrivals?" Control responded negative. No friendly aircraft scheduled. The signal strengthened as it approached. 35 miles, 32 miles, 28 miles. Lloyd assumed it was a German reconnaissance plane. At 24 miles, harbour control radioed back with a correction. "Unscheduled Sunderland flying boat from Gibraltar, bearing 094. Should arrive in 15 minutes. Parsons' improvised system had detected it at 38 miles. Standard chain home, range was 40 miles. "Close enough," Lloyd said. "Keep it running. The fighters stay." The first combat test came on April 30th at 7:23 a.m. The system detected a massive formation, 87 aircraft, 52 miles out. The RAF scrambled 3 Hurricanes plus 6 aircraft that were technically still undergoing emergency repairs. The fighters reached 18,000 feet before the bombers arrived. They shot down 4 German bombers and damaged 11 more. All RAF fighters returned safely. Under normal circumstances, those bombers would have caught the fighters on the ground and destroyed them. But the system worked too well and revealed new problems. It achieved 45-mile detection range, exceeding the standard chain home specification. However, it could only run 4 hours before the motor overheated catastrophically. The bicycle chain broke every 6 to 8 hours under continuous load. The underwater telegraph cable was corroding rapidly in salt air. The power drain was causing brownouts across the entire Dingley Cliffs area, affecting anti-aircraft batteries and communications equipment. Between May 1st and May 15th, the system detected 40 to 60 raids per day. Parsons was sleeping 90 minutes per day in 30-minute intervals, replacing the bicycle chain under active air raids, splicing corroded cables while bombers passed overhead. The mathematics of the situation were brutal. 60 raids per day required 15 operational hours minimum to cover critical periods. The system ran in 4-hour windows. That meant 4 complete motor cooling cycles per day, but raids came randomly. There was no way to predict when detection would be needed most. On May 16th at 2:30 a.m., during a routine maintenance cycle, the motor seized completely. The washing machine motor that had run for 17 days straight finally destroyed itself. No replacement was available on the island. Intelligence reported another major Axis convoy operation scheduled for May 18th with an expected 300-plus aircraft sortie, the largest yet attempted. Lloyd's message was direct. Find another motor, or we evacuate to Egypt immediately. Parsons searched every bombed building in Valletta. He found destroyed motors with wrong voltage, wrong RPM, wrong physical mounting specifications. He checked abandoned vehicles. He contacted every RAF station on Malta. Nothing suitable existed. On May 17th at 3:00 p.m., 31 hours before the convoy operation, Parsons heard about a bombed Italian submarine in the harbour. The submarine's periscope-raising motor might work. He dove into the harbour wreck without diving equipment, holding his breath. The submarine rested 65 feet down. He made 12 dives over 4 hours, finally extracting a motor. It was wrong voltage, 110 volts DC instead of Malta's 240-volt AC power grid. Parsons needed a transformer and rectifier to convert the power. He found a damaged transformer in a bombed electrical substation and rewired it in 6 hours. The first test resulted in the transformer exploding. He found a second transformer in a destroyed cinema and successfully converted power by 2:30 a.m. on May 18th, 5 hours before the expected convoy operation. At 7:30 a.m. on May 18th, the system detected the largest single formation of the Malta siege. 134 aircraft, bearing ZO-25, range 47 miles. A mix of Junkers 88 bombers and Messerschmitt 109 fighters targeting Grand Harbour in the RAF airfields. The RAF scrambled every operational aircraft, 9 Hurricanes and 4 Spitfires that had just arrived. They reached 22,000 feet before the bombers arrived, achieving perfect interception position. At 7:52 a.m., the system detected a second formation, 89 aircraft bearing 310, range 51 miles, a coordinated two-pronged attack. The RAF split forces, 7 aircraft to each formation. The first wave was intercepted at 8:04 a.m. RAF fighters destroyed 6 bombers and damaged 19. The second wave was intercepted at 8:11 a.m. 4 bombers destroyed, 13 damaged. Combined results, 10 bombers destroyed, 32 damaged, the convoy partially protected. All RAF aircraft returned, though 2 were damaged. But Parsons' radar system was being pushed to absolute limits. The periscope motor was running at 140% of its rated capacity. Temperature reached 340 degrees Fahrenheit. The motor was rated for 200 degrees. The bicycle chain had stretched to breaking point. The telegraph cables were smoking from current overload. At 8:47 a.m., the system failed completely. The motor seized. The chain snapped. The cables burned through. Total system destruction. But the convoy battle was won. 47 minutes of detection had been enough. The RAF had protected the supply ships. 3 of 4 convoy ships reached harbour. It was the first successful Malta convoy in 6 weeks. Between May 19th and May 20th, Parsons rebuilt the system again, this time using a more reliable motor from a destroyed German E-boat. He created a 4th iteration of the cable system using salvaged aircraft wire. The system was operational 68 hours after its catastrophic failure. From May through October 1942, the modified radar detected 847 major raids. The system failed and was rebuilt 23 times. Parsons averaged 3.2 hours of sleep per day for 6 months. RAF interception rates increased from 31% to 76%. Maltese civilian casualties dropped to 63%. Post-war analysis estimated 12,000 lives were saved. On October 15th, proper replacement radar equipment finally arrived from Britain, shipped through the Mediterranean in a heavily guarded convoy. A new chain-home low station with factory-manufactured parts, precision engineering, proper specifications. Parsons' improvised system was decommissioned. There was no ceremony, no official recognition. Flight Lieutenant Caldwell told him, "Hell of a job, Corporal." That was the extent of his acknowledgement. Parsons stood at sunset on October 15th, watching technicians install the new equipment. His washing machine motor sat in a scrap pile along with bicycle chains, submarine motors, and telephone cables. 6 months of desperate repairs were over. He processed that 847 detected raids meant approximately 12,000 people hadn't died. But he also thought about the 23 system failures. The raids on May 27th, June 14th, July 9th, and August 3rd, when the system was down for repairs. He didn't know how many casualties occurred during those windows. He didn't want to calculate that number. Between October 1942 and November 1945, Parsons continued radio repair duties. He was never promoted beyond corporal. He received no medal, no commendation. Radar operations were classified, top secret. His modifications were never officially documented. Flight Lieutenant Caldwell submitted a recommendation for the military medal. It was denied due to insufficient documentation. In November 1945, Parsons returned to Portsmouth and resumed civilian life. He applied for engineering positions, but was rejected because he lacked a university degree. He took a job as a postal clerk. He married in 1947, had 2 children, lived in council housing, and never spoke about his Malta work because it remained classified. He died on March 8, 1971, age 52, from a heart attack. In 1998, RAF documents were declassified under the 50-year rule. Dr. Margaret Hastings, a historian researching the Malta siege, found references to RDF-31 field modifications in maintenance logs. She found Parsons' name and tracked down his widow, Dorothy, who was 74 years old. Dorothy had never known the details of what her husband had done. Dr. Hastings analyzed raid data against RAF interception records and calculated that Parsons' system increased RAF effectiveness by 63%. She estimated over 12,000 lives saved and documented all 23 system failure and rebuild cycles. In May 1999, the BBC aired a documentary titled Malta's Secret Savior. It featured interviews with surviving Malta veterans, several of whom remembered the corporal who kept the radar running with bicycle parts, though none had known his name. The documentary was seen by 2.3 million viewers. In 2000, a small plaque was installed at the Dingley Cliffs radar site. Dorothy Parsons attended, along with 12 Malta siege veterans and RAF officials. The plaque reads, Corporal Edward Parsons, RAF, 1919 to 1971. His improvised repairs to RDF-31 radar station, April to October 1942, saved countless lives during Malta's darkest hour. Dorothy Parsons said he would have told you he was just doing his job. The number of people alive today because a Portsmouth postal clerk dove into harbours without equipment and kept bicycle chains turning under bomber formations is incalculable. Thousands, maybe tens of thousands. He never knew that. He died thinking his contribution was classified silence. He worked a regular job, lived a quiet life, never sought recognition, never wrote memoirs, never gave interviews. Just a corporal from Portsmouth who saw broken equipment and fixed it with whatever he could find. If this story matters to you the way it matters to us, hit that like button right now and subscribe. We're pulling forgotten stories from declassified archives every week. Drop a comment and tell us where you're watching from. Texas, Malta, Australia, Japan. Our community spans the entire world. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if someone in your family served. Just let us know you're here. Thank you for watching, and thank you for making sure Ted Parsons doesn't disappear into silence. These people deserve to be remembered, and you're helping make that happen.